Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video in which we'll go through everything you need to know for the upcoming test. So I'll divide this video into 3 sections. We'll start with number and decimals, then move on to percentages, and then to algebra. So let's start off with number. So one thing that we reviewed that is really important for you to know is BIDMAS, which gives you order of operations. So this list here gives you the hierarchy, the order in which you must perform operations. So you perform anything in the brackets first. After that is index or raising to a power. Then division and multiplication are sort of the same rank. You perform whichever occurs first from left to right, and similarly addition and subtraction are the same rank. So other than that, if something is higher on this list, you perform it first. For example, we perform division before we perform addition. So let's look at some examples. So let's say we have this here, 3 times 4 squared minus 11. So there's a few operations here, times, raised to a power, and a subtraction. So BIDMAS tells us that we have to do the index or raising to the power first, then the multiplication, and then the subtraction. So to show my working out, I'm going to work down the page with equal sign. Each line needs to equal the line above it. So first, I'm going to leave the 3 alone, and I'm only going to perform the raising to the power because index comes after brackets in BIDMAS, but there are no brackets here. So I get 3 times 16 minus 11. Next line, I now have 2 operations left, multiplication and subtraction. So I do multiplication first. So 3 times 16 is 48. Haven't done anything with the 11, so I'll leave it there. And then finally, I perform the subtraction. How easy is that? We also need to know how to do this involving negative numbers. Some people, for whatever reason, think that if we're performing operations involving negative numbers that BIDMAS changes, the order of operations changes. Well, no, it doesn't. Let's look at an example. So let's look at this question here. So once again, we have quite a few operations. We're multiplying, we're adding, and we're dividing. But this is a little different because some of the operations are in the brackets. So what I'm going to need to do first is what's in the brackets. Brackets is, of course, not an operation. What I'm going to do first are the operations in the brackets. So I have a times and a plus both in the brackets. BIDMAS tells us that I do multiplication before addition. So I'm going to do the multiplication first. So next line, minus 3 times minus 5. A negative times a negative is always a positive. So I'm leaving the 7 alone, and I'm leaving the minus 2 alone. So next, I have another operation inside brackets, which is addition. Normally, I would do division before addition, but since in this case the addition is in the brackets, I do that first. So each line has to equal the line above it, working down the page. Finally, I'm left with 22 divided by negative 2. So a positive divided by a negative is always a negative, all right? So you might get a question as well where you have to insert brackets to make a statement true. So let's look at one of those. Please pause and copy down these examples if you need. Look at this equation here in red. It turns out it's not actually a true statement because if I were to just do this left-hand side, what I would get is negative 2 plus, I do the multiplication first, so negative 3 times negative 5 is 15, positive 15 plus 4. Negative 2 plus 15 gives me 13. And of course, 13 plus 4 gives me 17. So the left-hand side is 17. 17 doesn't equal 1. Therefore, this equation is actually not true. So I'm going to rub out that working out. What I'm going to do is I'm going to insert brackets into this equation in order to make it true. So we need to think, where can I actually put brackets so that I will change the order of operations? I need to change the order of operations because the statement's untrue. So I could put bracket here and a bracket there, but that wouldn't, of course, change anything. I was going to do the multiplication first anyway, so let's get rid of those brackets So I could put brackets here and here. That would actually change the order of operations. But now I would get minus 2 plus minus 3, which is minus 5, times minus 5 plus 4. But minus 5 times minus 5 is positive 25. Plus 4 is 29. So that still doesn't work. So what I need to do is get rid of those brackets in black. That doesn't work. Now I've got to think, where else can I put brackets to make the statement true? Well, if I put brackets here, I would change the order of operations because I wouldn't be doing the multiplication first anyway. So now what I have is minus 2 plus minus 3 times, all that stays the same. Now in the brackets, minus 5 plus 4 is minus 1. Now, order of operations means I do the multiplication. I leave the minus 2 as it is. So minus 3 times minus 1 is positive 3, and minus 2 plus 3 in fact does equal 1. So if I put the brackets here, a statement becomes true. All right, let's move on now to decimals. So you all know what a decimal is. It's part of a number. A decimal is just another way we can write a fraction. But this year, you would have learned something new about decimals because we have different types of decimals, terminating and recurring. So terminating means stops and recurring means goes on forever. So what stops? What goes on forever? We're talking about the numbers after the decimal point. So some fractions, if you write them as a decimal, they have a terminating decimal, and some fractions, if you write them as a decimal, they have a recurring decimal. So for example, I'll put T for terminating. So 1 over 2 has a terminating decimal. If you write it as a decimal, it's 0.5. So just so you know, on your calculator, use the SD button, looks something like this to convert between fractions and decimals. So if you put 1 over 2 in your calculator, press equals, then press the SD button, you get 0.5. And of course that stops. There's one number after the decimal point, then it stops. Another example would be 1 over 16. If you do the same thing, put it on your calculator, press the SD button, you get 0.0625. So this one has 4 numbers after the decimal place, but then it stops. If you were, however, to put something on your calculator like 1 over 3, that's actually equal to 0.333. The 3's go on forever. They literally don't stop. Of course, your calculator can only show about 10 numbers after the decimal point. It can't, show you a million digits. Your screen's not big enough. But these 3's go on forever. Another example of a recurring decimal, something like 3 over 11. So it's equal to 0.272727, and so on. The 2's and the 7's go on forever. So in 1 over 3, only 3 was repeated, but in 3 over 11, there is more than one number repeated. So the way we write these decimals for convenience, because if we want to write 0.3 recurring, we don't want to have to write, heaps of 3's on our page. What we do is we write the decimal, and everything that's repeated just gets a dot above it. So the 0.3 with a dot above means 0.3 recurring. Similarly, for 3 over 11, we can write that as 0.27. Now in this one, both the 2 and the 7 are recurring. Put a dot over the 2 and a dot over the 7 because both numbers are repeated. Now, if we had something like 1 over 12, again, put that on your calculator, press equals, use the SD button. What you get is 0.08, and then you've got heaps of 3's going on. So in this one, we've got two numbers, 0 and 8, that are not repeated, but the 3's are repeated. So the way we write that, we don't put a dot above the 0 or the 8 because they are not repeated, but we do put a dot above the 3 because it is repeated. So we only put a dot above digits that are repeated. All right, now we're going to quickly look at converting fractions to decimals. So if we want to convert a fraction to a decimal, we can use short division. The good thing about this method, it will work whether the fraction has a terminating or a recurring decimal. So let's say I want to write 4 over 5 as a decimal. That is the same as 4 divided by 5, because this line here in the fraction means divide, 4/5. So we can look at that as how many times does 5 go into 4. So what we'll do is we'll just put a few zeros, because 4.000 is the same as 4. So how many times does 5 go into 4? Well, it doesn't, no times. So put 0. The decimal point always goes above the decimal point. So 5 goes into 4, 0, remainder 4. So we put the 4 here, the remainder, and now we say how many times does 5 go into 40, and that's 8. There's no remainder, so we can stop there. 4 over 5 is 0.8. So how would this work for a recurring decimal? So let's look at 5 over 12. So this is an example of one that will have a recurring decimal, but we're not going to do it any differently. This is the same as how many times does 12 go into 5. So whichever number's on the bottom is the one that goes outside here. So once again, I'm going to put a few zeros here because 5 is the same as 5.000. We just need enough zeros so we can see the pattern. So how many times does 12 go into 5? Well, it doesn't go into 5. It goes 0 times. Once again, decimal point above decimal point. 12 goes into 5, 0, remainder 5. So then we go, how many times 12 go into 50? Well, 12 goes into 50 4 times. 12 times 4 is 48, remainder 2. How many times does 12 now go into 20? It's 1, remainder 8. Now we say, how many times does 12 go into 80? Well, 12 times 6 is 72, and there's a remainder 8. How many times does 12 go into 80? It goes in 6, remainder 8. How many times does 12 go into 80? 6, and there'd be another remainder 8. But now you can probably see the pattern. We're just going to keep going like this forever. It's always going to be 12 into 80 is 6, remainder 8. That will go on forever. So we can stop here. We know that 5 over 12 is 0.41666666. And remember the way we write it? 0.416, only the 6 is repeated, so it gets a dot. All right, now we're going to move on and look at percentages. So remember, percent means per 100, and it's another way that we can write decimals or fractions. We saw before, we can write half as 0.5, we can write 5 over 12 as 0.416 recurring. A percentage is just another way to write those fractions and decimals, and we're writing per 100. So the good thing about percentages is it allows us to compare things. And it makes that a lot easier. So for example, if I got 42 out of 60 in my first maths test, I can write that as 42 out of 60. And let's say in my second maths test, I got 58 out of 80. It's hard to compare which of these is a higher mark. What we're doing with percentages, we convert them so it's like a fraction out of 100. Percentages are just fractions out of 100. And we'll be able to compare these so much easier. So it turns out, and I'm going to show you how to do this in a second, 42 out of 60 is 70 out of 100, but 58 out of 80 is 72.5 per 100, or 72.5%. We can write the first one as 70%. So that makes the comparison so much easier. The ones in blue, it's hard to see which is better, but we can see clearly 72.5% is more than 70%. So there are two types of questions that you need to be able to do. Finding a percent of a quantity and one quantity as a percent of another. So we're going to start with finding a percent of a quantity. So finding a percent of a quantity is pretty easy. You just convert the percent to a fraction or decimal, and we do that by dividing by 100, and then we multiply by the quantity. So I just want to point out this kind of question is where you already know the percent. The biggest mistake people make is they get the two types of percentage questions mixed up. So this first type is when we already know the percent. Let's look at an example. So let's do this question here. In a school of 1,200, 60% of students are boys. And we're going to find out how many are boys. So all we're really doing here It doesn't matter whether the question's about boys or, any other quantity. We're just finding 60% of 1200. So we're going to follow the steps above. Step 1, we convert the percent to a fraction or a decimal. So you just do that by dividing by 100. So 60 divided by 100 is the fraction. You can simplify if you want on your calculator. If you just put 60 over 100 equals, your calculator simplifies it to 3 over 5. If you want to make 60% a decimal, you just do 60 divide 100. So remember, that's the same as moving the decimal point 2 spots to the left. So it's just 0.6. Okay, now it doesn't matter whether you use fraction or decimal, we'll get the same answer. So I'm going to use the decimal here. So how many students are boys? I just go 0.6 times 1200 and I get the answer 720. So in this school, 720 students would be boys. So we also need to know how to apply this to financial math. So I'm going to rub out the right-hand side of this slide. Please pause and copy it down if you need. So let's try this question. A phone that normally costs $440 discounted by 20%, how much does it now cost? So you might be thinking to yourself, what does this have to do with finding a percent of a quantity? Well, hopefully you realize that if you buy anything and it's discounted by 20%, you're only paying 80% of the original price. So how much it will now cost is just 80% of 440. We know how to do this because we just did an example like it. It would just be 0.8 times 440, which gives us 352. Another way you could have done this is you could have found 20% of 440, which gives you $88. And because it's discounted by that much, the price would be 440 minus 88, and you get exactly the same answer of 352. Either way is fine. So let's look at this one. A cologne costs $52 per bottle to make. What would be its selling price if I place a 130% markup on each bottle? So what we're essentially doing is we're taking $52 and increasing by 130%. So in the previous one, we were taking $440 and decreasing by 20%. Now we're taking 52 and increasing. So if you want to increase something by, say, 10%, that's the same as finding 110% of the original amount. If you want to increase something by 25%, it's the same as finding 125% of the original amount. So here, we're actually finding 230% of 52. Okay, so whatever the percentage is by which you're increasing, you add 100 to that and make it a percent of a quantity question. So we're going to follow the exact same steps. We're going to convert the percent to a decimal or fraction. Again, I'm going to go with decimal, but fraction works equally as well. And then we times by the original amount. And you can just put that in your calculator to get $119.60. All right, I'm going to get rid of what's on the screen, so please pause and copy down if you need. So now we're going to look at what happens when you don't know the original amount and a percentage is applied. So let's look at this question. 15% of which number is 36? What makes this different is it's not saying find 15% of 36. It's saying what number, when you take 15% of it, gives 36. So we're saying 15% of what number gives you 36. So remember, 15% of something is the same as multiplying by 0.15. So whatever goes in the box, 0.15 times that number gives 36. So the answer will actually be 36 divided by 0.15. That's how we get the box on its own, and that ends up being 240. Because if you take 15% of 240, you get 36. So whenever you don't know the original amount before a percent has been applied, you must end up dividing. Let's look at a slightly harder question. So an item was discounted by 25%, now costs $135. What was the original price? So again, we've started with a number we don't know, we've discounted it by 25%, we've applied a percent to it, and we're left with $135. So we're finding the original amount. So here we don't want to go 135 divided by 0.25. Why? Because that's what we did in the previous question. Well, if it's discounted by 25%, that's not saying that 25% of the price is 135. What it's saying is that 75% of the original price is 135, because if you discount something by 25%, you pay 75% of it. So 75% of the original price is 135, so as I said, we divide. So the original price is just 135 divided 0.75, which is 180. If you discount 180 by 25% using the techniques on the previous slide, you get $135. All right, let's now look at the other type of percentage questions. Once again, please pause and copy down if you need. So all of the percentage questions I've done on this video to this point, they are all finding a percent of a quantity. Remember, we already knew the percent. It was like, 40% of something equals 10, or find 60% of 20. Here, we don't know the percent. We know the two quantities, and we want to convert it to a percent, and we use this formula here. So we already had a bit of a look at this before when we were looking at test scores. So let's look at that example again. So this question is one we've actually looked at on this video already. So I score 58 out of 80 in a test. What's my mark as a percent? So first quantity divided by second quantity times 100%. So if you just put 58 divided by 80 times 100, just put that on your calculator, you get 72.5 and add the percent sign. So that's the same answer we got before. We once again need to be able to apply this to financial math. So let's look at some financial questions. So an item that normally sells for $160 now sells for $120. What's the percentage discount? So here we know that the discount is $40, right? That's easy as. But what we want to do is turn that into a percent. And that's what these kind of questions do. So the discount is 40. I want to find what that is as a percent of 160. So discount divide original price times 100%. Again, you just put this part on your calculator and get 25. So the answer is 25%. If you take an item that's 160, discount it to 120, you've discounted it by 25%. So let's look now at a question involving markups. So let's say it cost me $60 to make a cologne. I sell it for $84. Now, what's the markup or profit as a percentage? So once again, we don't know the percentage and we want to find it. So here, this question is a little ambiguous and I should tell you more information. Do I want the markup or profit as a percentage of the selling price or cost price? Well, we know that the profit or markup in this case is just $24. If it costs you $60 for something, you sell it for $84, you've made a $24 profit. So, as a percentage of the cost price, so the cost price is what it costs me to make it, it would be profit, 24 over 60 times 100%. So, we're finding what percent of 60 is 24, and you get 40%. Now, as a percentage of the selling price, so the profit, is the same. It's gone up by 24, but the selling price is 84. So the cost price is what it costs me to make it or buy it, and the selling price is like what the customer pays for it, what you actually sell it for. So to do that, it's going to be 24 divide 84, first quantity divide second quantity, times 100%. And if you put that on your calculator, to the nearest whole number, it's about 29%. So the markup is about 40% of the cost price and 29% of the selling price. All right, we now move on to algebra, our final section of the video. So we look at algebra, which is basically the study of operations. And yes, it's that topic that has all the letters or the pronumerals in them. So we're going to start by looking at substitution. So that's really simple. It's just where you exchange a pronumeral for a number. So let's say, for example, I have a plus 1. So if I tell you that a equals 4, I can substitute it into the expression. So a plus 1 is an expression, and I can change a to be 4, because that's what the question's telling me. So a plus 1 would just be 5. How easy is that? Let's look at a more complicated example. So now we're looking at two pronumerals. A and B are pronumerals. They're letters in place of numbers, and we're going to evaluate this expression. So I'm just going to do what I did in the previous example and substitute in. So I get 2 outside of A plus B squared. Now you have to be careful when you're squaring a negative number. When you put it in your calculator, you need to put brackets around it, otherwise you'll get the wrong answer. Whenever you square a negative number, the answer is always positive. So minus 3 squared is positive 9. If you got negative 9 on your calculator, you've done something wrong. So this would be 2 outside of negative 2 plus negative 3 squared is positive 9. So remember, if no operation is written, we assume it's times. So this would equal 2 times negative 2 plus 9, which is 7, and that gives us a total answer of 14. Now we're going to look at operations with terms. Please pause and copy this down if you need. So we look now at operations with terms. Now, if you have something like 2a plus b minus c, this is called an expression. It's just, heaps of numbers and pronumerals together. So each of these things that makes up the expression is called a term. So 2a is a term, b is a term, and the last term is not c, it's negative c. So note 2a and plus 2a are the same thing, right? So we don't need to write the plus for the first term. However, for the last term, we need to have the negative there, because negative c and c are not the same thing. So this expression has 3 terms. So now you know what terms are. We are going to perform operations. We're going to add, subtract, multiply, and divide them. So we start with addition and subtraction. So it turns out that in order to add or subtract terms, they must be like terms. So that means they have the same sequence of pronumerals. So for example, x and 4x, they are like terms. You can add them together or subtract them because they both have an x. Something like 7 and 7b, they are not like terms because one of the terms, i.e. 7b, has a b, the other one doesn't. It doesn't matter the order of the terms, of the letters, sorry. So if you have something like 4ab and negative 3ba, they are like terms. They both have 1b and 1a. The order doesn't matter. If you have something like x squared and 5x, they are not like terms because this term has 2 x's, this has only 1. They don't have the exact same sequence of pronumerals. So we could add together the terms here and here, but not in the other 2 examples. So when you're adding or subtracting the terms, you just add or subtract the numbers in front of. So if you have something like 7x minus 3x, 7 minus 3 is 4, and you write the pronumeral. How easy is that? If you had something like a plus 5a, well, remember a and 1a are the same thing because when you times something by 1, you don't change it. That would just be 6a. Say you had something like this, 7y minus 2 plus 5y minus 3. So this is an expression, and it has 1, 2, 3, 4 terms. Now you have to group them in like terms. So 7y and 5y are like terms. 7y plus 5y is 12y. We do them separately. And then minus 2 and minus 3, they are like terms. You know you can add and subtract minus 2 and minus 3. So it's minus 2 minus 3 gives minus 5. Now this cannot be simplified anymore because 12y and 5 are not like terms. I can't subtract them. So I leave my answer like this. All right, I'm going to rub this out so we can do multiplication and division. Please pause and copy this down if you need. So when we're timesing and dividing, the terms actually do not need to be like terms. So as I said before, you can only add or subtract terms if they're like terms, but you can still multiply and divide them. Why is that? Well, let's say I had something like 3 times 2a. Well, you know that timesing by 3 is the same as adding something to itself 3 times. I can do this because 2a, 2a, and 2a are like terms. I just add the numbers. 2 plus 2 plus 2 is 6. So that's why we can multiply terms even if they're not like terms, because multiplying is adding something to itself many times. So in this case, similar to when we added and subtracted, you just operate on the numbers in front of. So 3 times 2 is 6, and then I write the a. So if I have something like 4y times 3, I just go 4 times 3, is 12, and then write the y. Let's say I have negative 7b times 2c. So I go negative 7 times 2, and then I write the letters b and c. Now if I have something like this, x times, say, 4x. So I just write the number 4. Now, x times x is x squared. So I want you to remember this because people always mess it up. X plus x gives 2x, whereas x times x equals x squared. So make sure you know that. So division works sort of the same. So let's say I had something like 12a divides 6. So you just go 12 divided 6 is 2, and you can write the a's. It becomes a little more challenging when we have to involve cancelling. So if I have something like 12x over 20, so I have to simplify this. I go 12 over 20 is 3 over 5. You can use your calculator for that, but I still have my x there. So it's 3x over 5. Now, if I have something like 24xy divided by 6x, sometimes when you're doing divisions, it's much easier to write as a fraction. So I can write 24xy divided by 6x. Now, when you're simplifying fractions, remember you can cross out common factors. So x and x cancel out because they're on the top and the bottom. On the previous example here, there was only an x on the top. That's why I didn't cancel it out. So we know that x times x is x squared, but x divided by x, assuming x isn't 0, is just 1. So the answer here would be 24 divided by 6 is 4, and I still have a y there. Okay, once again, please pause and copy down if you need. We are now going to go on to expanding and factorizing. Expanding and factorizing are the things involving brackets. So you start with something like this, and you might end up with something like this. So going this way that I've just done, where you start with brackets and end up without, that's called expanding the brackets, and you use the distributive law to do that. Going the other way, you start without brackets, end up with brackets, is called factorizing. So the reason it's called factorizing is you are writing it as something times something. You are writing 2x plus 6 as the product of factors. So let's go through how to actually do this. So the distributive law for expanding says if you have a outside of b plus c, you distribute the a to the first thing in the brackets, and you distribute the a to the second thing in the brackets. So let's look at some examples. If we have, say, 3 outside of x plus 4, we go 3 times x, 3 times positive 4, which is 12. So if we have a negative out the front, we do this similarly. Don't try and do it any differently. Minus 7 times 2x, so that's a negative times a positive, which is a negative, and then minus 7 times not 1, but minus 1. Minus 7 times minus 1 is positive 7. Sometimes you might have like an a out the front, a pronumeral. If it was a outside of 2a minus b, you go a times 2a, which is 2a squared. and then a times negative b is just negative ab. So sometimes you will have to expand and simplify. So let's say I have something like 7 plus 2 outside of 3 minus x. So order of operations, because this is a times, you do this first. You don't do 7 plus 2 is 9 first. You do what's in red first. So I leave the 7 alone. 2 times 3 is 6. 2 times negative x just gives me negative 2x. Now I need to collect like terms. 7 plus 6 is 13, and I leave the 2x alone. Sometimes you'll get a question like this. You have to expand 2 brackets at once and simplify them. So we expand the first bracket. 4 times 2x is 8x. 4 times negative 3, obviously negative 12. Now this isn't a 5, it's a minus 5. So I go negative 5 times x, negative 5 times positive 1. So negative times positive is a negative. Now I need to collect like terms. 8x minus 5x is 3x. And then I have minus 12 minus 5, which gives minus 17. And that's the final answer. So that's expanding. Let's look now at factorizing. So let's say I have something like 3x plus 9 and I want to factorize it. So the ones you'll be factorizing will have 1, 2 terms. 3x and positive 9. They are each a term. So what you do is you find the highest common factor. So the highest thing that goes into 3x and 9, which is 3, that goes outside the brackets. So inside the brackets, you go 3x divided by 3, which is x, 9 divided by 3, which is positive 3. Okay, so inside the brackets, you divide each of the terms by the highest common factor. If I were to expand this using the distributive law, I would get my original answer. So that's a way for you to check. So if I had something like 12x minus 20, the highest thing that goes into 12x and 20 is 4. So what's 12x divided by 4? Or if you like, what do I times by 4 to get 12x? And the answer is 3x. What do I times by 4 to get negative 20? And it's minus 5. So once again, if I were to expand this using the distributive law, I would get my original answer. Now, sometimes the highest common factor involves a pronumeral as well. So let's say I had 24xy minus 30x. So the highest number that goes into 24 and 30 is 6, but there's also an x in both terms. That's part of the highest common factor too. So what do I times by 6x to get 24xy? I need to times by 4 to get to 24, and I need to times by y as well. What do I times by 6x to get negative 30x? It's just negative 5. 6x times negative 5 gives negative 30x. Right, now for a hard one. Let's say I had minus 35x squared y minus 63xy squared. So just so you know, xy squared here means only the x is squared. So there are 2 x's, but only 1 y. And in this one, only the y is squared. So there are 2 y's and only 1 x. So once again, we have one term and another term. So highest common factor. So the highest common factor of negative 35 and negative 63. So because they're both negative, we'll take a negative out the front. The highest common factor of 35 and 63 turns out to be 7. So I put a negative 7 there. Now both of them have an x and a y, so we take out xy at the front. That's the highest common factor, negative 7xy. So what do I times by negative 7xy to get this? Well, I need to times by 5 to get to negative 35 and x to get the x squared. What do I times by negative 7xy to get this? I need to times by positive 9 to get to negative 63, and I need to times by another y to get the y squared. We are done. Once again, if you expand this using the distributive law, you get this. All right, our final thing that we need to go through is index laws. Once again, please pause and copy down if you need. So if we have something like this, you're probably aware that it means that you multiply this number this many times. So it's just 4 times 4 times 4, and of course that just gives you 64. So we call this number that's being multiplied the base, and this small number is called the power or the index, hence the name index laws. So writing it like this is called expanded form. So if you're ever asked to write in expanded form, it's something times by itself a number of times. And this is the answer you'd give if it said evaluate or give the value of. So we're looking at laws involving powers. So we know, for example, if we have 2 to the power of 5 times 2 to the power of 2 in expanded form, that would give us 2 to the power of 5 is 5 2's, and then 2 to the power of 2 is 2 more 2's. So there are 7 2's. In this expression, 2 is being multiplied by itself 7 times. So what you can see here, 2 to the power of 5 times 2 to the power of 2, we have kept the same base, and we've just gone 5 plus 2 is 7. We keep the same base and add the power. So that is the first index law. If you multiply the bases, you keep the same base and add the powers. Similarly, if you divide bases like this, you keep the same base and subtract the powers. So once again, I'm going to go onto a new slide to show you some examples. Please pause and copy this down if you need. So if I have something like 2 to the power of 7 times 2 to the power of 8, you keep the same base and add the powers. 7 plus 8 is 15. So this is in index form. You'll often be asked to give your answer in index form, which means write it as something to the power of something. So like 3 to the power of 20 times 3 to the power of 11, keep the same base and add the powers. So it works for the other laws that we went through as well. If I have like 12 to the power of 8 divided by 12 to the power of 4, keep the same base. Now the power here isn't 8 divided by 4, it's 8 minus 4, which is 4. If I, use pronumerals, it works the same way. If I have y to the power of 13 divided by y to the power of 5, keep the same base and subtract the powers. Sometimes you might have to use both laws at once. So if I have something like 8 to the power of 6 times 8 to the power of 7 divided by 8, so 8 to the power of 6 times 8 to the power of 7, keep the same base, add the powers. Now 8 and 8 to the power of 1 are the same thing. So I can write it as 8 to the power of 1, keep the same base, 13 minus 1 gives me 12. All right, we're almost there. We just need to look at 2 more index laws. So let's say I had something like a to the power of 2 to the power of 3. So this 3 means I times this, what's in the brackets by itself, 3 times. So the first index law says keep the same base and add the powers. 2 plus 2 plus 2 is 6. Hopefully you notice we've just multiplied the powers here. So that's another index law that you need to know. A to the power of B to the power of C, keep the same base and multiply the powers. Of course, this is referred to as the power to a power rule because there are 2 powers, 1, 2. All right, the other index law was the 0 index law that we went through. So I know that 2 to the power of 4 divided by 2 to the power of 4, so you keep the same base and you subtract the powers, right? But 2 to the power of 4 is just 16. 16 divided by itself is 1. So 2 to the power of 0 must equal 1. So the index law here is anything to the power of 0 is not 0, it's 1. You can't raise 0 to the power of 0 though. So 2 to the power of 0 is 1, 3 to the power of 0 is 1, 5 to the power of 0 is 1, minus 207 to the power of 0 is 1. So let's look at examples putting all these index laws together. So if we were doing a question like this, so we'll do the brackets first. 12 to the power of 3 to the power of 5. Keep the same base, multiply the powers. Okay, now 13 to the power of 0 is just 1, because anything to the power of 0 is 1. So the answer to this is just 12 to the power of 15, divide 12 to the power of 4, keep the same base, subtract the powers. We don't need to worry about this 1 here, because dividing by 1 doesn't change our answer. That's it for the video. Thank you so much for watching. As a thank you to some people for watching, the first 10 people who watch this and then come and find me in person and say Elsie's is a soccer star, you'll get a lollipop. Just a little thank you. Please ask any questions. Best of luck studying for your test, but you'll ace it because you're a superstar. Once again, sorry about the length. This has been the luckiest maths teacher in the world. Have a great day.